Chapter 2, Section 2, Solving Two-Step Equations. Remember, when solving equations, our goal is to get a variable by itself or solve for a variable. You might also hear isolate the variable. Isolate just means to get it by itself also. To do this, we have to use inverse operations. If you remember the inverse operations, remember inverse means opposite. So the inverse or opposite of addition is subtraction. This goes both ways. So the opposite of subtraction is addition. The inverse of multiplication is division, and the inverse of division is multiplication. The first example is a one-step equation. We have x minus 3 equals 2. Remember, when solving an equation, you ask yourself, what are you doing to the variable? So if you look at the variable x, we are subtracting 3 from x. In this case, we need to do the inverse of subtracting 3. The opposite of subtracting 3 is adding 3. Whatever you do to one side of an equation, you have to do to the other to keep it equal or balanced. We can call this adding to both sides the addition property of equality. The addition property of equality states that adding the same number to each side of an equation produces an equivalent equation. Notice that you have to be adding the same number to each side. So in this case, I'm adding 3 to both sides of the equation. When we talk about sides of the equation, we're talking about each side of the equals sign. When you add 3 to both sides, your answer for this equation is x equals 5. Remember, to check your answers, you can solve or plug in 5 for x. When you do so, you get 5 minus 3 equals 2, and that is a true statement, so we know that my answer is correct. The next example says x plus 7 equals 10. In this case, I'm adding 7 to my variable. The opposite or inverse of adding 7 is subtracting 7. Whatever you do, you have to do to both sides. Well, 7 minus 7 is going to make this go away. This subtracting from both sides is called the subtraction property of equality. Subtracting the same number from each side of an equation produces an equivalent equation. When I subtract 7 from both sides of this equation, I find that x equals 3. Again, I could plug 3 in for x, and I have 3 plus 7 equals 10. That is true, so I have checked my answer, and I know that x equals 3. The next example says x divided by 2 equals 6. Well, the opposite of dividing by 2 is multiplying by 2. Whatever you do, you have to do to both sides. This is called the multiplication property of equality. It states that multiplying each side of an equation by the same non-zero number produces an equivalent equation. When you multiply by 2 on both sides of this equation, you find that x equals 12. Again, plug 12 in for x. 12 divided by 2 equals 6. That is true, so I know that I have the correct answer. The final one-step equation example says 4x equals 24. Remember, anytime you have a number and a variable written right side by side, just like 4x is here, that means that we are multiplying. The inverse of multiplying is dividing. In this case, I need to divide by 4. Whatever you do, you have to do to both sides. This is called, you could probably guess by now, the division property of equality. It states that dividing each side of an equation by the same non-zero number produces an equivalent equation. In this case, when you divide both sides by 4, 4 divided by 4 goes away to just having 1x equals 24 divided by 4 is 6. Again, I could plug in 6 for x. 4 times 6 equals 24. That is true. I know that I have the correct solution. When we're solving two-step equations, it says to solve a two-step equation, you have to perform 2 operations. So far, we've only performed one operation or done one-step equations. To do this, we have to reverse the order of operations, which basically means to undo addition or subtraction first and then multiplication or division. Now, this statement is true for most cases, but we are going to do an example here in a minute where we do not get rid of addition or subtraction before the multiplication or division. And we'll talk about why we might not do it in that order here in just a minute. The first example of two-step equation says, what is the solution of 2x plus 11 equals 51? I have my original equation. Remember, I just said, generally speaking, I need to get rid of addition or subtraction first. In this case, that is true. I am adding 11 to my variable x, so I need to do the opposite or inverse, and I need to subtract 11 from both sides. Well, 11 minus 11 is 0, so it's going to go away. So I'm left with 2x equals 40. Now, to solve for x, I need to divide both sides by 2. When I do that, I find that x equals 20. Remember, for when you're solving equations, you can always go back, plug it in. So 2 times 20 is 40, plus 11 equals 51. And that is true. I do know that x equals 20. The next example says a train is 100 miles away from a station. It is approaching the station at 40 miles per hour. How long will it take for the train to arrive? I can write an equation saying that 40 miles per hour, so 40 times the number of hours that I've traveled, I need it to equal 100. So I have 40h, where h is hours, equals 100. To solve for h, I need to divide both sides by 40. And when you do that, you find that h equals 2.5 hours. Or you need to travel for 2.5 hours to get to the train station that is 100 miles away. This is the example that I was talking about earlier. It says, what is the solution of x plus 5 over 6 equals 15? I'm going to rewrite the problem here. Notice that x plus 5 is all being divided by 6. If you remember when we talked about the order of operations, we talked about the fraction bar or division bar being the same as a grouping symbol like parentheses or brackets. Now, because x plus 5 is what is being divided by 6, I cannot subtract 5 yet from both sides. I need to get rid of my dividing by 6 first, because subtracting 5 I would not be able to do because it's not just a 5, it's a 5 divided by 6. So first I need to get rid of dividing by 6, which means I need to multiply by 6 on both sides, which gets me x plus 5 equals 90. Now I can subtract subtract 5 from both sides because it's just a 5. It's not being divided or multiplied or anything by any other number. So now I can do the opposite of adding 5, which is subtracting 5, and you find that x equals 85. Again, we're always going to look back to our original equation. We can say that 85 plus 5 is 90, and 90 divided by 6 is 15. So we have checked our solution. The last example says, what is the solution of 10 plus 2x equals 20? And it also asks us to justify each step. We can use the properties that we talked about at the beginning of this lesson to justify each step. I'm going to first rewrite my problem. If you notice, this is written in a little bit different order, but that doesn't matter. I have 10 plus 2x equals 20. So if you look at the variable x, it's being multiplied by 2, and then we're adding 10 also. Remember, I'm not dividing x, or my whole number 10 by anything, so I do get rid of the addition first. The opposite of a positive 10 is a negative 10. If you remember, subtracting 10 from both sides is called the subtraction property of equality. So that's my justification. I can subtract 10 from both sides because if I subtract the same number from both sides of an equation, then it keeps the equation equal. When you subtract 10, you wind up with 2x equals 10. Now I need to divide both sides by 2. How I can justify this step would be the division property of equality. Remember, when you're dividing both sides of an equation by the same number, it keeps the equation equivalent. When you divide both sides by 2, you're left with x equals 5. Again, I can plug it back into my equation. 10 plus 2 times 5 is 10, so 10 plus 10 equals 20, and that is true. The assignment for today is on page 97. It's numbers 6 through 40 even.